Welcome to Web Handling. My name is Dave Roisum. In this video, we describe if and when a dancer reduces tension upsets. There are several aliases for damping, as well as several ways to define it. Here, we will use the engineering definition as a reduction of tension oscillation after the dancer. Specifically, we quantify the goodness of the dancer in this regard as the ratio of the output tension oscillation over the input tension oscillation. Obviously, the smaller the output oscillation or ratio, the better. In layman's terms, this desirable aspect might be thought of as a shock absorber similar to what you have in your car. So, does a dancer damp out tension oscillations? The answer is, it depends. Sometimes it does, sometimes it does not, sometimes it even makes things worse. Everyone hates the answer, it depends, because it often does not answer the question. However, in this case, we know very well what it depends on. It depends on the characteristic frequency of the tension disturbance that comes to the dancer. If the frequency is high, the dancer reduces vibration. If the frequency is low, it does little to change the vibration. However, middle frequencies are actually made worse. So, it depends. It depends on frequency. For those techies in the audience, this concept is called transmissibility. It is the ratio of the output over the input tension oscillation versus the characteristic frequency of the disturbance. The diagram shows this dependency quite well. While there is a benefit at high frequencies, at intermediate frequencies the dancer system goes into resonance and may make things worse. This work by Shen was done nearly 2 decades ago. It was based on a simpler viscous damping, even though a better description of real dancers is Coulomb friction. So what applications are best served by dancers in this regard? Well, they would include high-frequency upsets such as rotary die cutters, very high-speed unwinds with out-around rolls, as well as turrets during the turn-up. Most other applications are either unchanged or, as often the case, made worse. What is made worse is that the Coulomb friction destroys the resolution and sensitivity of the dancer system as a drive sensor, as well as greatly complicating the tuning. Thank you so very much for watching this module in my Plant Practical series. Please stay tuned for more dancer and other web handling topics.